Hello and welcome to NASA Science Live. Today we're featuring a special climate edition on NASA's innovations and efforts to help improve the environment. I'm your host, Jasmine Hopkins. Since Earth is our home planet, today's conversation is not just about us. We want to hear from you. So we invite you to join the conversation using hashtag AskNASA in the comment section wherever you are watching. Now, let's dive right in. NASA does much more than explore space. In fact, many of the technologies NASA developed for space missions are also used to help protect planet Earth. And although much of the climate-related news these days is pretty grim, today we are happy to introduce you to some positive solutions. I have two special guests joining us to do this right now. So we'd like to welcome our NASA experts. First, we have Dr. Kate Keldon, NASA Chief Scientist and Senior Climate Advisor. Welcome, Kate.
Hi.
And Dan Lockney, Technology Transfer Program Executive in NASA's Space Technology Mission Directorate. Welcome, Dan.
Hi, Jasmine.
All right, so first we want to start by getting to know you a little bit better. So Kate and Dan, can you tell us a little bit more about your roles here at NASA? Kate, we'll start with you.
Yeah, thanks, Jasmine. So I'm NASA's Chief Scientist and Senior Climate Advisor, and there's a few different aspects of that role. So part of my job is to serve as an advisor to NASA leadership on all things climate and on science more generally. I also work to connect within the agency. We have a lot of climate and science throughout our agency, and I work to connect those aspects internally. And then I spend a lot of time communicating what we do with the public and people like you.
Thanks so much, Kate. And Dan?
I love my job. So at NASA, I have the responsibility for ensuring that the technologies and innovations we create for our space missions and aeronautics activities, all the cool stuff that we get asked to do, that those ideas, concepts, and innovations, technologies come back down to the Earth in the form of practical terrestrial benefits that improves our lives, saves lives, boosts the U.S. economy, and just cool gadgets and things we have in our life as a result of the neat work that NASA gets to do.
Thanks so much, Dan. Glad to know that you love your job here at NASA. You guys both have excellent positions within the agency. So today we're going to talk about NASA and the technologies that benefit Earth and the life on it. These have many touch points throughout the agency, but first we want to talk about something that many of our viewers can relate to, and that's either driving in a car or flying in a plane. So Dan, can you explain how NASA technology is improving the way we travel more sustainably?
Absolutely. So the first A in NASA is aeronautics. And if you've been on a plane, it has benefited from NASA research. And there's countless ways that it has. But one of my favorites goes back a couple years, and it's the blended upturned winglets. And that's if you've seen these aircraft out on the tarmac or in the sky, you've got that edge of the wing folded up a little bit. Now, intuitively, if you ever made a paper airplane, curled up the wings a little bit, like shown here, you throw it across the room, it just flies a little bit better. But our NASA engineers did that with metal, attached it to airplanes, real airplanes, and it turns out it works on the real ones too. And it improves fuel efficiency, allows for steeper takeoff so that it's quieter above in the areas directly around airports. So you could put residences a little bit closer. And it overall makes the airplane fly a little bit smoother. And that's been around for 20 plus years, and it's on every Boeing aircraft. And they've estimated billions of gallons of fuel saved. There's a new technology called digital winglets that very similarly, it takes its name from the original metal winglets, very similarly makes air travel a little bit safer, more convenient, more efficient. And it's this neat concept where the plane and the ground can communicate with one another and redirect a flight path to get a plane to change its altitude or direction in order to avoid turbulence, avoid bad weather, find more efficiency in the route, and then also not collide with other things in the air. This neat digital winglet concept that planes can reroute from their original fixed flight plan and get us there safer and more efficiently. And just two of the many ways that NASA tech is in with you when you fly.
Thanks so much, Dan. And I hear that you mentioned fuel and efficiency a couple times there, which is important to the agency as well as the United States. So the U.S. has a goal to achieve net zero emissions from aviation by 2050. Kate, can you tell us how NASA is supporting that goal?
Yeah, absolutely. So, as Dan mentioned, we've worked with the aviation industry for decades to reduce energy use and emissions associated with flying. And we are continuing now to work on reducing those emissions and energy use even further. And we work in different areas. So we work on airport operations as well as aircraft design. And one of the things we're working on is a new experimental plane or X plane called the X-66A. And the X-66A is a change in the design of the airplane and the materials used to build it in a way that will reduce the amount of energy used and emissions associated with flying even more and help us get towards net zero emissions from aviation.
That is wonderful to hear. Thank you so much, Kate. We are already seeing questions pour on online. Please keep those coming to us. And remember, you can join the conversation using hashtag AskNASA or posting something directly into the comment section wherever you are watching. So our first question comes from a viewer on X saying, fascinating topic. Can you share any specific examples of NASA technology improving energy efficiency on a large scale?
Kate?
Go ahead, Dan.
Okay. So one of my favorites, this is several years old, but it takes a while for technology to be adopted and then to become ubiquitous. And then you ask for large scale, and that doesn't happen overnight. So this is several decades old. But in the 1970s, there was an engineer at Marshall Space Flight Center in Alabama who developed this voltage control device that changed the amount of energy an electric motor used according to how much load was on that motor. And we used it for saving energy in space, saving energy in everything that we do, automation and robotics. We want to save energy. The practical application here on Earth, though, is every escalator, every elevator, and every moving sidewalk that's been built in the world since the 1980s has this device in it that NASA invented. And we know this is true because there's a limited number of manufacturers of elevators, escalators, moving sidewalks. I think there's 4 who make all of them. And they all use this device. And the concept is pretty straightforward, and I'll describe it. If you call an elevator to your floor and it's empty, it now knows and senses that it's empty and uses less electricity to bring the elevator to your floor, versus prior to having this device, the motor didn't know, and it would always operate at full speed. So in terms of large scale, picture every escalator, every elevator, and every moving sidewalk you've ever seen, and they all have this device on them.
Thanks so much, Dan. That is a great example of large scale. NASA is always with us, whether it's on an escalator or an elevator. Next, we have Roland on X, and he asks, what tech is NASA looking at most in terms of renewable energy? What about 30 years from now? Where do you hope we will be at in terms of our ability to harness renewable energy?
Yes, I guess maybe I'll start and then Dan can add on that. So I think we work I think about this in a few different ways. One of the areas we work in is providing information to people around the world about what's happening on Earth so they can better plan their own energy use and, respond to things happening in their community. And so a lot of our space-based data and Earth satellites can help us understand that and understand what the possibilities are in the future. But we're also an agency that is thinking about our own environmental footprint. And so we take a lot of actions at our centers and our facilities to improve our climate resilience and reduce our energy use. And so there we think a lot about what is possible where we are and what can you do with the different parts that we operate in around the country.
Thanks so much, Kate. And we actually have another question to you, Kate. You mentioned it before, but can you explain what is net zero for the net zero emissions?
Yeah, absolutely, and I probably should have explained that from the start. So net zero is means when any positive emissions from human activity are balanced by removal. So if you are putting greenhouse gas emissions into the atmosphere, you're also taking out an equal amount, so that the net total is zero emissions. And the reason that's important to scientists is when we get to net zero carbon dioxide emissions, that's what we need to do in order to limit warming. So as long as carbon dioxide emissions are positive, warming will continue. And so in order to halt warming, we need to get to this net zero. And so that's what we think about, is balancing those emissions with removals.
Perfect. Thank you so much for adding that explanation, Kate. Now we have a viewer on YouTube asking, is there technology that could improve the impacts of pollution?
Dan, do you want to start on this one? I think you yeah.
Absolutely. So there's several ways to reduce pollution. One is to prevent it from happening in the first place, and the other one is try to mitigate the results of it. And we're doing work in both of those areas. One of my favorites, and this might sound smaller scale than every escalator you've ever seen, but we developed a device to scrub the air of pollutants for spacecraft that has since been applied to toll taker booths on highways, so that the people who have to stand there and collect your $2 when you go through the booth and pay the toll to cross the bridge or keep moving on the highway, that air is cleaner now as a result of research that NASA's done. We've also done, you know how plants clean the air? Like, everyone kind of knows this. We intuitively knew it, but NASA proved it. We tested it. And it came as a result of early space station designs, when it was all inorganic materials, plastics and glues and no windows, because you can't really pop open a window in space. We're trying to figure out how to make these contained environments. We realized that crews training in these simulated environments were getting headaches. So we experimented with plant growth in these chambers in order to see if we could use them to clean the air, and it turns out we could. And then we tested to see which plants would provide the most clean air, which plants would be the best to grow. That was a couple years ago, but now when you go to Home Depot or Lowe's or wherever you buy your house plants, the things you find in your home, in the houseplant section, the Norfolk pine, the different ferns, and all of those things, it's not a coincidence that those are the plants that you find in the store. Those are the ones that the snake plant, all of those were on the list of NASA's top air cleaning plants. So everything from large scale to small, the house plant that you're looking at in your living room, we're a little bit everywhere.
Thanks so much, Dan. Again, a good reminder that NASA is everywhere around us. Okay, we're going to switch gears now to talk about our next topic, but please keep those questions coming online using hashtag #AskNASA. So now we're going to go into wildfire detection. Kate, can you tell us how NASA is improving the ability to spot wildfires so that first responders can know about them sooner?
Yeah, absolutely. I think wildfires is an active area of study for us, and we're really trying to help both understand fire as well as help our first responders respond to fires. And we work in different areas, so looking at before, during, and after a fire, and provide different information for each. So before fire, we can provide information on where there's dry vegetation conditions, where you might have fuel for fire. During a fire, we can look at where there are active fires. So we have a platform called FIRMS, or the Fire Information for Resource Manager System. And you may have actually seen this on the news, but it's showing you where there are active fires now. And it's using several satellites to pull information from space about where those fires are. But we're continuing to work now to make sure we can get information to first responders quickly and efficiently so they know what's happening and how to respond. So we work closely with people like the U.S. Forest Service and the Bureau of Land Management, trying to understand the challenges they face in fighting a fire and thinking about what we can do to help improve their response.
Thanks so much, Kate. It's great to know what we're doing to keep our first responders and the public safe. So next, Dan, NASA technology is also helping improve ecosystems. Can you give us a few examples of how?
I could. I also had some firefighter ones, but you can always call me. My information's always available online, so I'm easy to find, and I could do this all day. So ecosystem. Another weird fun one is we think of beavers, we all do, as destructive animals that just go chop down trees. And for decades, centuries, hunters and farmers would try to eradicate the beaver, thinking it was just a nuisance animal. It turns out, though, there's an advantage to having these dams, that they prevent the drying up of wetlands. And with the removal of beavers, we ended up with longer, straighter, deeper rivers, and then drier areas around them. So using NASA satellite data, researchers are now trying to figure out where in the US that they could repopulate beavers, with the intention of not having a significant impact on the human population, or putting the beavers where they shouldn't be. And this picture, by the way, is one of the ways we attract beavers. That's a man-made dam meant to entice a beaver to, it's a head start on a beaver dam. Those clearly weren't chewed by a beaver. But the idea is that we would help the beavers repopulate these areas, and it would reduce runoff, it would reduce the drought, and it would overall improve the watershed. Satellite data to help repopulate beavers in the U.S.
Thank you so much, Dan. I can't help but love all those pictures of beavers. And like you mentioned earlier, NASA is kind of everywhere we look, including in our food. So now let's talk agriculture, which is where our food is grown and harvested. Kate, how has NASA technology helped farmers, for example?
Yeah, two ways that we can help farmers. One is through Earth observations. We can help farmers better plan their crops and fields. So we're able to observe crops from space so we can see what's growing. We have satellites and instruments that can tell us things about soil moisture, drought conditions, plant health. And we can use that to provide information to farmers about when to plan and their irrigation. So we have a tool called OpenET that can help farmers in the US understand how much water their fields are losing and better plan the irrigation for that. And farmers have used it and they've saved a lot of water while still producing crops and growing food that we can eat.
Thanks so much, Kate. Again, great to see how NASA is affecting our daily lives. And speaking of that, let's get back to those viewers online. So first we have Debbie on YouTube asking, how will going to the moon again help us to better understand our own planet Earth and to plan for a more sustainable future?
I guess I'll start with that one. So one of the things that, we learned from going to the moon is, it's part of our solar system, and it contains a history of our solar system. So by learning about the moon, we can learn more about Earth. From a science perspective, but also in our process of going to the moon, we're developing a lot of technologies and learning a lot that can help us with sustainability on Earth. So when we think about going to space, we have to bring everything with us. And so we're very careful about how much weight we put on, what we think about doing in space. And a lot of the research that we do to get to space and live in space helps us right here on Earth. So we have a lot of challenges around food, around energy. So we have a challenge called Watts on the Moon that's looking at power on the moon and energy storage, but it also can help us with power and energy storage here on Earth. So we're always thinking, we're going back to the moon for science, but we're also learning about Earth and taking that technologies here to benefit us.
Thanks so much, Kate. Yes, learning a lot about Earth from the moon, and we'll have some more information on those challenges later in today's program. So next we have Enter to Infinity on YouTube asking, how is net zero possible? What are the technology advancements used by NASA to accomplish this?
Great. So I'm going to talk a little bit about net zero in general, and then I'll talk about the part that NASA is working on. So in general, there's two aspects of net zero. It's reducing emissions as well as removals. And some of the ways you can remove emissions from the atmosphere are things like planting trees. So trees take carbon dioxide out of the atmosphere and can help counterbalance any positive emissions. For NASA, the main part that we're working on achieving the US goals on net zero is through our aviation. So we do research on aircraft so that we can reduce the environmental impact of flying. So when you do fly, it has the minimal environmental impact. And that's the primary way that we've been doing research on technology related to net zero. But we also monitor Earth from space so we can see where you've planted those trees and monitor changes in forest cover over time, as well as in forest health.
Thanks so much, Kate. We have a lot of interest in net zero. Next, we have Todd on X and asks that he has been riding a bicycle for the last 30 years. Very nice. He wants to know if 50% of the people, if 50% of people did this, would that be the power saving impact and carbon emissions that we need?
That's a great question. So one of the things, there are people that do research on what happens if you change the way you travel and what that means for emissions. And I don't have the precise numbers off the top of my head, but one of the ways you can reduce emissions associated with travel is by walking, biking, or public transit. It's not available to everyone, but it does tend to be lower emitting than other ways of travel. So there would be emissions reductions if people did bike and walk, but not everyone has access to that.
Thanks so much for that answer, Kate. Dave on X asks, does humanity have an ability to directly scrub CO2 or methane from the atmosphere?
So there are ways of removing carbon dioxide from the atmosphere. I mentioned trees before. There's also other ways. So one of the things we actually do on our spacecraft is we capture carbon dioxide out of the spacecraft just to provide clean air to astronauts. It's at a small scale, the level of a few astronauts, but there are people doing research into technologies that are larger scale versions of that. So Department of Energy is responsible for that. But there are different ways of removing carbon dioxide. The one that people are most familiar with probably are trees.
Thanks so much, Kate. We have another one asking, can anyone use NASA's climate technology? This might be a question for Dan.
Yes, anyone can use it. We have several portfolios. One is a software portfolio at software.nasa.gov, and that's free to the public to use. You can search it by keyword and hunt through it and find something that might be of interest to you. We also have our patent portfolio, which is available for licensing, and that's at technology.nasa.gov. Again, keyword searchable, and some of the keywords will help you hone in on what you're looking for. But there's also bins that you can search, for example, environmental or climate tech. But yeah, take a look. There's a ton of technology and a lot of opportunities out there.
Thanks so much, Dan. We actually have something related to that, as NASA technology is for everyone. Darth on YouTube asks, Dan, if I, as a non-US citizen, want to use some of the NASA technology I found on the NASA Technology Report server, is the Small Business Innovation Research and Small Business Technology Transfer Program the only way?
Darth, there's three different questions in there. First, the technology available is on those two sites that I mentioned, software.nasa.gov and technology.nasa.gov. The NASA Technical Report Server, the NTRS, is actually all of our scientific publications, and that's data, content, knowledge that we've published that we want people to have to know and to use. It's somewhat different than the technology side of things. And then third, the Small Business Innovation Research and Small Business Technology Transfer Research programs are not necessarily for NASA technologies, but rather they're solicitations where we ask people help us solve a problem. We provide funding for them. And that is only available to U.S. citizens. But that SBIR and STTR programs both are innovative, small dollar research contracts and grants to help people advance their own commercial potential with technology, but then also help NASA meet a mission need. So, Darth, that was a complicated answer. Check out the websites, and if you get confused, you can always shoot me a note.
Awesome. Thank you so much, Dan. We appreciate you telling that NASA is an open science, open technology agency, and we hope to see some involvement after today's show. Remember, you can continue to send us those questions by posting them directly in the comment section wherever you are watching or using hashtag AskNASA. So now we've talked agriculture, aviation, and now we're going to get into energy. Over the years, humans have developed systems to harvest and store energy from sources such as wind, sunlight, and tidal action. And these are known as renewable and alternative energies that can be replenished in a short period of time. So, Kate and Dan, how has NASA helped expand renewable energies across the globe?
Yeah, thanks, Jasmine. Maybe I'll start and then Dan can add some specifics. One of the ways when we think about, climate change is driven by greenhouse gas emissions principally, and we think about ways we can reduce greenhouse gas emissions, some of the options that have really high potential to reduce emissions are things like wind and solar. And we have there's a lot of research on wind and solar, some solar research at NASA, but a lot also at the Department of Energy. But one of the other things we do at NASA is help people understand what the potential is where they live. So we have an application called Power, the NASA Power app, and it will tell you what the what renewable potential is where you are. So it takes information about incoming solar radiation and wind, and provides information about renewable energy, so you know what's possible where you are. And I think maybe Dan, you have some other specific examples, perhaps.
Ton of them. We have this website, spinoff.nasa.gov, and we call these practical terrestrial benefits, these products and services and technologies and devices and things that make our everyday life better as a result of NASA's research. We call them spinoffs. They're spinoff of the original research. And we have thousands of them online. One of them is one of my favorites. So we're building this big rocket that's going to take astronauts to the moon and then to Mars. Big rocket, biggest rocket that's ever been built. Beautiful thing. And during the design phase, they discovered that it was vibrating pretty violently on the launch pad. This is all computer design. This is not, up on the launch pad like, whoops, we made a mistake. This is, during the design. And as Kate mentioned earlier, we're very conscious of weight restrictions when we're talking about launch and space travel, because you got to leave Earth and you can't have it too heavy. And if something was vibrating on Earth, you could just put a stack of books on it or something, or like weight it down with concrete or put a rock on it. You can't do that with the vehicle that you need to have leave Earth. We'd even changed at this point the paint job on the rocket to save weight. Like that's how dialed in we were with trying to save weight on building this rocket. But it's vibrating. So we realized we had to find a solution that didn't add a lot of weight. And the researchers who were working on it, the engineers and physicists, developed a system of baffles that would insert into the liquid fuel tank. And when you look at the rocket, like the big NASA rockets, that's mostly liquid fuel. And the little action part on top is that big, and the rest of the rocket's most of the rocket. So that liquid fuel, that's most of the mass. And they determined that if you can control the slosh of that liquid fuel as it's burning down very quickly, if you could manage that, you could transmit the stability to the rest of the vehicle. That solved the problem without adding a ton of weight. We quickly then realized that we could put that in skyscrapers, tall buildings, and high rises for earthquake mitigation in areas that were prone to high winds. But as we got going with it, we then realized, we say we, not me, the scientists and physicists who are working on this very interesting problem. They started working with some researchers up at the University of Maine who were trying to build wind turbines, offshore wind turbines that 5-10 miles off the shore would float on the sea and then collect wind and turn it into energy. And these things would get beat up by the Atlantic. I mean, storms and salt water and it's not an easy place to have a piece of equipment floating around, bobbing up and down. And they discovered that putting these baffles that stopped the rocket from vibrating underneath the floating platforms of these wind turbines, they could provide stability to the turbine, allowing it to not get beat up as much and to be a little more predictable in its operation. So the estimate is that they would extend the life by at least 10, 15 years of these ocean-bound floating turbines. And it all came from NASA building a big rocket that's going to the moon. And that goes back to Debbie's question that what do we expect humans are going to get out of going to the moon? And there's certain things, like Kate mentioned, the saving power and learning about recycling of air and water, and the vantage point of space. But for me, it's all the weird stuff that we don't expect. Like, did you know we're going to build this rocket, run into this vibration problem, and next thing you know, it's over in wind turbines off the shore of Maine. And that's the fun part of innovation and exploration.
Thank you so much, Dan. So from a moon rocket to wind turbines to the NASA Power app, I appreciate you both for tag teaming that answer on renewable energies. As a reminder to our audience, please continue sending us our questions using hashtag AskNASA in the comments section wherever you're watching. And now we'll get back into that Q&A. So King's Throne on YouTube asks, what is your stance on embracing regenerative agriculture to move CO2 from the atmosphere into the soil?
I think, as a science and technology agency, our view is that we provide scientific information and technology about what is happening and what might happen. So we do a lot of monitoring of Earth soils and as well as plants from space, and so we can provide that kind of information. But our primary role is in providing scientific information and in technologies.
Thanks so much, Kate, for taking that question. Now a viewer on YouTube asks, is NASA involved in any energy storage solutions?
Absolutely. It's yes and yes. I will tell you a quick one. And this one goes back a few years. Remember when those, I forget what they're called, things people got them for Christmas, you'd stand on them, they had two wheels, and you'd kind of like roll around on them, and people would fall and bust their teeth out. And rollerboards, I'm going to call them rollerboards. You know what I'm talking about. When those first came out, in addition to people falling and getting hurt, remember they were also lighting on fire, like fairly regularly. And remember back 15 years ago or so when like laptops would light on fire, like that was a thing. These lithium ion batteries were like, they're great new technology. They were lightweight, held a lot of energy, but occasionally they'd light on fire. And NASA solved that problem because we wanted to use the batteries too, but we didn't want them lighting on fire in space because, well, you can't really get the fire department up there as quickly as you'd like. You'd have to train them and get them up. And it's a mess. So the simpler thing is to avoid the fire altogether. So NASA researchers went out to the Department of Energy and they studied how to make these lithium ion batteries not light on fire. So you might be saying, but Dan, they don't light on fire. That's correct. We did that. But we've been working in power storage and generation in numerous ways for decades.
Thank you, Dan. Masterful storytelling. I didn't know how you're going to connect the lighting on fire, NASA, but you did it. All right, so moving on to our next question. A viewer on YouTube asks, what are NASA's plans for helping civilian and commercial industry for small nuclear reactors or green hydrogen tech?
I think I'm not the best person for that. We do have people that think about both hydrogen as well as nuclear, but I don't know if Dan has any examples there, but that might be a better question for one of our other colleagues in space technology.
The only thing I would add is if we had technology that NASA developed in those areas, we would make them available to the public.
Awesome. Thank you so much, Dan and Kate. Next, a viewer on X asks, great to hear about NASA's innovations helping our planet. Could you share about how these technologies improve renewable energy or make travel more efficient? I think you guys have both touched on that, but anything else to add?
Make travel more efficient.
Well, on the renewable energy, I think the one thing we haven't really talked about, we talked a little bit about our Earth observations, we talked a little bit about wind turbines. We haven't talked about solar as much now. So we use a lot of solar power in space. Most of our satellites have solar panels. The International Space Station does, and we've developed a rollout solar panel. I don't know, Dan, you want to give more details on that?
Sure. There's actually two different rollout solar arrays that we've developed. One of them is kind of neat. So you picture a solar panel, and it's this fixed, rigid thing. And you picture it like bolted to the top of a house or a building. So NASA developed rollable, deployable ones that we launch them into space, and you don't want to launch this big flat like a sheet of plywood into space. We want this like tube, like a rug that you could roll out. So we developed these rollable solar panels. That same concept has been applied to simple ones that you could take camping or hiking or roll out on a picnic, charge your radio, your telephone, and you kind of just like take it out of your backpack and roll out this solar panel. That's kind of a small scale version for charging a single device. There's another neat one we've been working on, because in addition to rolling them out, you also want to make sure they're not like delicate, and that they can withstand a little bit of a beating, because space launch is difficult and it's kind of rough on things. And then rolling something out and just having it float out in space is also, you want to make sure that it's strong and that you can't easily pop up to repair it. So we developed these solar panels that you can attach to a building or between two trees like a hammock, or even put it on, say, the top of a gazebo or pagoda, that'll withstand weather and wind and take a beating outdoors. And then when you're done using it, you can roll it back up. And the neat advantage here is that you could actually have solar power delivered to your home without having to go through the expense and permanency of actually bolting those rigid ones to your roof. So this would work if you were, say, renting, or if in a circumstance where you had to set up emergency tents or something in an environment like a field hospital. You could put these things out, and they would withstand rough weather, and you could roll them up and pack them away when you're done.
Thank you so much, Dan and Kate, for those examples of solar energy. Glad that we were able to loop that into the conversation as well. Sam on YouTube asks, what are potential future endeavors in terms of finding various renewable energy sources? What are the crucial factors taken into condition for this purpose in the point of view from NASA scientists?
I think we're continuing to explore both our home planet as well as space and learn as we go. And you never know what you might find. I think that's one of the fun things, particularly as Dan mentioned about his job. When you're looking at one challenge, you might find solutions to another. And so I think we're always exploring, we're always learning, we're always understanding, and we're always sharing. So we share what we can with the world.
Thanks so much, Kate. Yeah, it's nice to see how many missions might affect others here at NASA. So a viewer on Twitch asks, how do plant satellites imagery aid in overall food production and growth?
So I think we've got a number of different ways that we're able to study plants from space. So we can see what's growing. We have a satellite called Landsat. It's actually a series of satellites in partnership with the US Geological Survey. And we have more than 50 years of records of this. And it can tell you where there are trees, where there are crops. And we've worked, with people like the US Department of Agriculture to identify which crops. You can tell from space what's growing by when it greens, the precise color that it is. We have other satellites that can tell us about plant health. So we have an instrument on the International Space Station called EcoStress that it measures temperature at this really, really high precision. And what it turns out you can learn from that is when plants are water stressed. So when plants don't have enough water, they get a little bit hotter. So they get a fever. And we can see that from space. And so this instrument that can show us urban heat islands can also let us know when plants have water stress. But we're continuing to learn about agriculture and learn what we can do to provide more information to farmers about what's happening and what might happen in the future. So we also have an active area of research around looking at future crop yields and future crop production to understand how changes in the environment in the future might affect our ability to grow different crops.
Thanks so much, Kate. Yeah, we're doing. Dan, would you like to add?
I do. Well, we also have some fascinating research being done down at our Kennedy Space Center in Florida on vertical farming. And when Kate mentioned sensors, we use sensors to dial in exactly on what a plant needs. So rather than having to use, just throw more water at it, just hope for the best, put more light on it, take a little light off, and kind of see what happens. We can read plant health and stress up close, and figure out, oh, it needs a little more of this nutrient. It needs a little bit more of a little bit more water, a little less water. Maybe it needs a little more wind passing through. Maybe the temperature's not quite right. And we can grow perfect crops with very little, if any, fertilizers and no pesticides necessary, because this is largely done indoors. The way we were working on it at NASA was plant growth for long duration spaceflight. And these banks, these walls of plants that you could eat, lettuces and such, don't require a lot of growing medium. It's not like your Miracle Grow soil. This is, generally a goo that they grow in, a nutrient dense goo. Sometimes it's water, hydroponics, but a very light base, and then a wall of sensors, and you grow the plants off of it. So the cool application, and by the way, we just made this information publicly available. We said, have fun, you all grow some plants. The cool thing is there's multiple companies now that are farming this way, and you're seeing in dense urban environments. So as the planet gets more populated, we're going to have more people. They're going to be in urban environments, and we're going to have fewer ways to feed them good, green, healthy food, and we're going to have less farmland. So growing these plants indoors in order to feed people is kind of neat. And you can literally, in cities on the East Coast and the West, purchase now when you go to the grocery store lettuces that were grown indoors, and you virtually indistinguishable from the other lettuces that you might find. And yes, it's primarily the lettuces right now, but the sky's the limit on what you could grow in these neat vertical farms.
Thanks so much, Dan, for that addition. And yes, lettuce is a start, but we have much more coming. A viewer on YouTube now asks, what are the experts most excited for to see technology that is being developed right now?
Are we the experts?
That's a great question. Most excited. I have to say, every time I hear about something that's happening, I get excited about it. So it changes. Since we were just talking about food, I always like learning. On the International Space Station, we grow crops. So our astronauts are farmers. And they've done a lot of research on things like LED lighting, on fertilizers that we use in some of those indoor agriculture facilities that Dan mentioned. And it's kind of fun to think about what we can learn. And it's also fun to think about growing crops in space. But we have a lot of other fun sort of research around food, around energy, and you never know what we'll learn next.
Thanks so much, Kate. A lot to be excited about. Dan, would you like to add what you're most excited for?
I'm going to fall back on one of my other answers, and I'm most excited about what we don't know yet, and the wacky places that we're going to see technology turn up. Like, one of my favorite stories is a few years back. Not climate related at all, but we developed a device at request for a marching band in Michigan that needed a way to keep their reeds warm for the wind instruments during sub-zero marching season. So yeah, we got that battery technology. You can use that, because otherwise you'd be kind of like stuck on your reed, and then you'd take it out and it would freeze. In order to prevent that from happening, we made these reed warmers, and there was no way we could have predicted that. And it helped some people, and some kids didn't get chapped lips as a result, and they played their instruments. And I don't know, but that's the fun part. That's why I love my job. Like, who knows what's around the corner?
Awesome. Thank you so much, Dan. So growing plants in space and then reed warmers, lots to be excited about here at NASA. So Kate, you just mentioned this, but a viewer on X asks, as an engineer who's worked on space launch systems and now the International Space Station, what is a major contribution NASA has made to life on Earth? And we have an amazing station powering things, from solar, maintaining livable atmosphere, a water recovery system. How do those improvements help us on Earth?
Yeah, so we talked a little bit about food, but now I'll talk about water. So one of the other things we do on the International Space Station, we need to make sure our astronauts have clean water to drink. And so we recycle water on the International Space Station. And we've done a ton of research on water filtration and water recycling. And that's been used all around the world in places where they don't have access to clean water.
Thanks so much, Kate. Yes, bringing that benefit right back here to Earth. So are you using an AI in any of these innovations? And I think that question can go to both Kate and Dan.
So we use AI and machine learning. I'm trying to think about if we've mentioned anything yet, but I will instead mention things we're doing going forward. So we use a lot of AI and machine learning. We have for decades. It's how we land a rover on Mars. But some of the things we're doing that are Earth and climate related involve sort of using AI and machine learning to better track and identify features in satellite imagery. So we have some scientists that have counted trees in northern Africa using machine learning. They taught the computer what a tree looks like, and then they could count trees all across a large portion of Africa. We also have people that are working on tracking wildfire emissions. So when a wildfire burns, there's a lot of smoke from it that causes air quality concerns, not just where the fire is, but also pretty far from it. And we're able to track that from space and model that, but we've used machine learning to make that faster. So if you can track where the smoke is going, you can put out air quality alerts and help people, particularly those that have asthma or other respiratory conditions, understand what the air conditions are like outside.
Thanks so much, Kate. Dan, would you like to add?
Of course. So this is very specific. Back to machine learning and tracking of large data sets and making sense of rapidly of these large data sets. We developed an algorithm and a tool for making sense of all of the reams of data that were coming back from the Hubble Space Telescope, making sense of these star patterns. We started working with researchers at the University of Florida to use the same tool to track whale sharks, because whale sharks have a distinctive spotting pattern on their bodies that, much like the human fingerprint, remains the same for the entire life of that animal. So we were able to, with photography, and much more readily than swimming up and tagging them with GPS sensors, we were able to. Oh, you have a whale shark picture. We were able to rapidly determine and accurately determine where these whale sharks were and track their migratory patterns, and that helps us keep an eye on this endangered species. So then similarly, these researchers at the University of Alaska found out, and then much like the human fingerprint and the markings on the whale shark, they explained to us the polar bears have a distinctive marking on their muzzles, a spotting pattern that stays the same for the life of the animal. So polar bears are easily recognizable, right? If you know what to look for, by the markings on their snouts. So now, if you wanted to track migration and populations of polar bears in Alaska, rather than have to sneak up and tag them or learn all their names, what you would do instead is you could snap photographs of them, and other people could snap photographs, and you could put all this data together, and then using those Hubble star tracking tools, determine which polar bear you snapped a picture of. And then finally, there's the human fingerprint, there's the markings on the whale shark, there's the snout of the polar bear. A dog's nose is like the human fingerprint, distinct to that animal, and every dog has its own nose print that is that dog's, and they're distinguishable by that. There's no NASA technology there, but isn't that awesome? The dogs each have their own little nose markings. I love it.
That is fascinating. Thank you so much for that answer, Dan. So now we're going to switch to the topic of carbon. A viewer asks, is NASA actively pursuing carbon sequestration and carbon dioxide technologies?
So I think the primary way we work in this area is around sort of monitoring Earth, in particular things like land, so forests and other ways that people might remove carbon from the atmosphere. And so we're able to monitor that and see what's happening and track that over time. And we don't just look at where there are trees. We also have an instrument on the International Space Station called JEDI that can give us information about how tall those trees are and the canopy structure. And that can help us really understand how much carbon's coming out of the atmosphere. I think the other thing I would just mention here, I mentioned earlier that one of the other things we do is think about our own operations and facilities. And at Kennedy Space Center, they've done mangrove replanting. So we've actually planted mangroves and try to keep the coastal ecosystems really healthy. And those can take a lot of carbon out of the atmosphere.
Thank you so much, Kate. I always love hearing about what NASA is doing, even at our center level. So now a viewer on Twitch asks, how do you acknowledge the reality of climate change while keeping good mental health?
That's a great question. And as a climate scientist, I think I get this a lot. And I think we do have to acknowledge that, temperatures are rising and they are causing impacts to people and ecosystems all around the world. And we see devastating impacts across the world, including close to home in the United States. And that is a reality. And as a scientist, we are trying to, and a science agency, we're trying to better understand what's driving that, provide that information publicly, and help people understand what the actions are where they live. I would say for me personally, someone once told me that science is hope. So I like to think about what we're doing at NASA or what scientists are doing around the world. And we know what's driving climate change, which means we know how to stop it. And there are people working on this every day. And people like Dan figuring out how things that we might not have thought of as climate can help us address climate. And that helps me every day.
I'll go back to Todd also. I think his name was Todd. The guy rode a bike for 30 years, riding a bike.
Yes.
I mean, not only does it help, but like exercise is great for the mental health and good for the environment.
Awesome. Thank you so much for adding that, Dan. And Kate, I mean, mental health is extremely important, so we're really glad we got a question on that. So unfortunately, that looks like all the time we have today to take your questions, but thank you so much, Dan and Kate, for taking the time to be here with us and answer them. I'll give you now a chance to say goodbye to our audience.
Thank you so much, Jasmine.
Thank you all. A lot of fun.
All right, and thank you to everyone who joined us online. We had some fantastic questions come in today, and we love getting to engage with you, our viewers. So you can learn more about NASA technology and stay up to date on the latest innovations by following NASA Technology on both Facebook and X. And you can also learn more about the NASA transfer or technology transfer and spinoff technologies by visiting NASA's spinoff website. There are also some fun ways that you can get involved in our sustainability efforts, and the NASA Luna Recycle Challenge is one of them. So this is a $3 million competition that invites innovators, just like you, to design recycling solutions to reduce waste for long-term missions on the moon, like we'll do with Artemis. So the challenge may also inspire us to improve how we reduce, reuse, and recycle right here on planet Earth. You can help us inspire better sustainability on and off the planet by going to go.nasa.gov/Luna Recycle Challenge. And finally, we invite you to stay updated on all that is happening here on planet Earth and how we're protecting the people on it by going to NASA Earth on Facebook, Instagram, and X. Thank you so much again for joining us, and we hope to see you next time on NASA Science Live.